OpenAI, the company behind ChatGPT, is now being sued in a class action lawsuit for allegedly stealing tons of people's data and profiting from it.
What if we told you that there is a new AI supercomputer that can outperform GPT-4, the most advanced language model in the world? And what if we told you that there is a new natural language framework that can make your Apple devices smarter and more responsive? Sounds too good to be true, right? Well, it's not. It's real. And it's happening right now. Today we're going to talk about Meta's next-generation AI supercomputer, OpenAI's GPT-4, and Apple's natural language framework. First, let's talk about Meta's next-generation AI supercomputer, which they call the AI Research Supercluster, or RSC for short. Meta, formerly known as Facebook, announced the RSC in January 2022 and said that it will be fully built out by mid-2022. The RSC is designed to accelerate AI research and help Meta build for the metaverse, which is their vision of a virtual reality platform that connects people across different devices and applications. The RSC is based on a custom-designed hardware and software architecture that can handle quintillions of operations per second, making it one of the fastest AI supercomputers in the world. The RSC will enable Meta to train and run more advanced AI models that can learn from trillions of examples, work across hundreds of languages, analyze text, images, and video together, and develop new augmented reality tools. One of the main applications of the RSC is natural language understanding, or NLU, which is the ability of a computer to understand the context and meaning behind human language. This technology will allow for more sophisticated interactions between users and their devices, as well as between users and other users in the metaverse. So, which one is better, Meta's RSC or OpenAI's GPT-4? Well, it's hard to say for sure since both technologies are still in development and have not been fully tested or evaluated by independent researchers. However, based on what we know so far, we can make some tentative comparisons. First of all, both technologies are impressive feats of engineering and innovation that push the boundaries of what AI can do with natural language. They both use massive amounts of data and computation to create increasingly sophisticated and capable language models. They both have potential applications for various domains, such as education, healthcare, entertainment, social media, and more. However, they also have some differences that may give them some advantages or disadvantages over each other. In comparing the RSC and GPT-4 models, it is important to consider their respective strengths and limitations. The RSC is designed with a focus on Meta's specific use cases and vision for the metaverse, which means it may not be as generalizable or adaptable as GPT-4 for other domains or tasks. Additionally, the RSC is more specialized in natural language understanding rather than natural language generation, which may make it less creative or expressive in producing text. However, the RSC is more integrated with Meta's platforms and services, which may give it an advantage in terms of accessibility and usability for Meta developers and users. On the other hand, GPT-4 is more open source and collaborative, which may benefit from more feedback and contributions from the wider AI community. GPT-4 is also more scalable and flexible, which may allow it to handle more diverse and complex inputs and outputs than the RSC. Finally, GPT-4 is also more aligned with human values and ethics, which may make it a safer and more trustworthy option than the RSC. Of course, these comparisons are based on our current understanding of these technologies, which may change as they evolve and improve over time. Ultimately, we will have to wait and see how they perform in real-world scenarios and how they impact society at large. Tokenization involves breaking up a piece of text into linguistic units or tokens. Parts of speech tagging involves marking individual words with their corresponding part of speech, while lemmatization deduces a word stem based on its morphological analysis. Named entity recognition helps identify tokens as names of people, places, or organizations. Finally, text embedding is the process of finding similarities between pieces of text. Apple's NL framework also allows developers and users to train and deploy custom natural language models using create-ML, a tool that simplifies the process of creating machine learning models. For example, one can create a text classifier model that can categorize natural language text into predefined classes, or a word tagger model that can tag individual words in natural language text with custom labels. Apple's NL framework is integrated with many of Apple's products and services, such as Siri, the virtual assistant that allows users to interact with their Apple devices using voice commands, QuickType, the keyboard that uses NLP to predict what a user is going to type next, and natural language search, the feature that allows users to search for files on their Mac using natural language queries. Apple's NL framework is also available for third-party developers who want to incorporate NLP functionality into their apps and services. Apple's natural language NL framework is unique and innovative due to several key features. First, it provides support for over 50 languages and scripts, including some that are not widely supported by other NLP frameworks, such as Amharic, Cherokee, Georgian, and Icelandic. Second, it utilizes on-device processing and differential privacy techniques to safeguard user data and privacy. No user data is sent to Apple servers or third parties unless the user explicitly opts in. Third, it leverages Apple's neural engine and core ML frameworks to optimize the performance and efficiency of the NLP models. The models can run on various Apple devices, from iPhones and iPads to Macs and Apple Watches. Finally, the framework provides an easy-to-use interface and documentation for developers and users. Developers can use a Swift or Objective-C code to access the NLP functionality, and the framework also offers sampler code and tutorials for various NLP tasks. But how does Apple's NL framework compare to Meta's RSC and OpenAI's GPT-4? Well, again, it's hard to say for sure since they are not exactly comparable in terms of scope and purpose. However, we can make some general observations. First of all, Apple's NL framework is more focused on providing basic and essential NLP functionality than advanced and cutting-edge NLP functionality. It may not be as powerful or capable as Meta's RSC or OpenAI's GPT-4 when it comes to handling complex and novel NLP tasks. Second of all, Apple's NL framework is more user-friendly and developer-friendly than Meta's RSC or OpenAI's GPT-4. It may be easier and simpler to use than Meta's RSC or OpenAI's GPT-4 for both end users and app developers. It may also be more compatibly and integrated with Apple's ecosystem than Meta's RSC or OpenAI's GPT-4. Third of all, Apple's NL framework is more privacy-preserving and security-conscious than Meta's RSC or OpenAI's GPT-4. It may be more respectful and protective of the user's data and preferences than Meta's RSC or OpenAI's GPT-4. It may also be more compliant and transparent with the user's rights and regulations. Of course, these observations are based on our current knowledge of these technologies, which may change as they develop and improve over time. Ultimately, we will have to wait and see how they perform in real-world scenarios and how they impact society at large. That concludes our episode on Meta's next-generation AI supercomputer, OpenAI's GPT-4, and Apple's natural language framework. We hope you enjoyed this episode and learned something new about these exciting developments in the field of natural language processing. If you did, please give this video a thumbs up and share it with your friends. And don't forget to subscribe to our channel for more news and insights.